Hi guys, welcome to my tutorials. Today we will learn about the curve fit in MATLAB. The aim of the command is to write a code to fit a linear and cubic polynomial for the predicted CP data, and write a code to show splitwise method, measure of the fitness characteristics for both the curves. Here first we load the data. Uh, First we load the CP data which is given to us. Then we'll calculate the temperature, then CP data. Then we calculate the temperature, which is the first column of the CP data. CP is equal to CP data column comma 2, means this is the second column of the CP data. Then we will calculate the curve fit is good or bad. We'll calculate here the R square, the RSME, okay, the SSE, SSR. We use for loop for each value of temperature and CP data. Each value of some temperature and CP data, we'll calculate xi and yi. Then we'll calculate SSE, SSR, R square, then adjacent R square and RSME. Then after calculating, we get the value of R square. If the R square is greater than 0.95, then the curve fit is good. Otherwise, the curve fit is not good. Curve is not good fit. Okay. And then we'll plot the figure. We plot the curve. Here, the plot temperature CP line with 3. This code will give us the curve for temperature and CP, the actual curve. And here this plot predicted CP line with 3 color R. This code will give us our predicted curve. This is the splitwise method. Here we split the total into 8 parts. The first part is from 1 to 400. Here we calculate the CP1, CP data 1 to 400. Like this, we'll calculate total 8 set of data points. Then finally we'll splitwise मेथड में हमें ये कर्व मिल रहा है फास्ट ऑर्डर पोलिनोमियल का, एंड द सेकंड कर्व इज ये है द कर्व फिट फॉर फास्ट ऑर्डर पोलिनोमियल, ये हमें मिल रहा है. अब हम इसको थर्ड ऑर्डर के लिए हम चेक करेंगे कर्व फिट फॉर थर्ड ऑर्डर इक्वेशन. ये है थर्ड ऑर्डर इक्वेशन. यहाँ पे भी हम सेम ही लिखेंगे प्रोग्राम को. सीपी डाटा लोड करेंगे, टेम्परेचर सीपी डाटा कैलकुलेट करेंगे, देन हम कोएफिशिएंट्स कैलकुलेट करेंगे बाय यूजिंग टेम्परेचर एंड सीपी डाटा यूजिंग द पॉलीफिट कमांड. इफ आर स्क्वायर इज ग्रेटर देन 0.95, then display curve is good fit, else display that curve is not good fit. Then this is the figure 1 for the third order polynomial. Splitwise method is also same as before. We will use the first data set as from 1 to 400. Here we calculate the temperature value, then CP data, then coefficients, then predicted CP, same as before. Here for I is equal to 1 is to length of CP, which is 3200. We calculate the xi value, yi value, and SSE is equal to sum of x, SSR sum of y. Then we will calculate r square, which is SSR by SSR plus SSE. Then k is equal to 0, n is equal to length of CP, adjacent r square is equal to 1 minus r square into n minus 1 divided by n minus k minus 1. RSM is equal to SQRT, square root of SSC by n. Then we will calculate r square is equal to 0, r square is greater than 0.95, display curve is good fit, else display curve is not good fit. And then we'll plot the figure 2, which is plot temperature CP, and then we'll run it. This is the curve fit, which is perfectly fit to the original curve. Now our curve is in green color and the original curve is in red color. But here this is not perfectly good fit. This is not perfectly good fit. Here we will check the command window for the result. This is the command window. Here r square is equal to 0.5, adjacent r square 0.5, RSM is equal to 5.4277. Curve is not good fit as the r square value is 0.50, so it is much less than 0.95, so the curve is not good fit. But here the r square is equal to 1, adjacent r square is equal to 1, RSM is equal to 0.0621, so curve is good fit.